Hello, I want to talk here today because some issues are between Rviz and Gazebo and your model. And that's not an issue because the software is wrong, it's because you caused it. So let's see here that we have our model is over the ground, and let's cause some issues to see how to attack those problems. If I take some time is because I'm reading here a script about the issues and try to figure out how to replicate it. So let's start with the first issue. The first issue is your model is sinking a little bit below the ground. So let's see. The first thing is to check the PID controllers. So there is some relationship between the PID controllers, the ROS controllers, the transmission tag, and also Gazebo. So let's over exaggerate our PID control here to see something odd. Okay, let's see. Okay, I don't know if you could see very well here, but the model is below the ground. So one cause of the problem that your model is below the ground are the PID controllers. So next move to another cause that will make your model sink on the ground. For tuning the PID control, you can use anything that you learn on the university. You first start with P with low values, then keep it up by, multiples of tens, and also when you're satisfied with the P control, you go to the I control. When you're satisfied with the PI control, you go to the P controller. Or you could use Ziegler-Nichols method or any other ones to tune your PID. So now let's run it again to see that the model is not syncing, just to see it. Okay, here you see the model is over the ground. So I will let you see it a little bit. The model is over the ground. Now let's cause another issue for check to see if the model gets below. I have the here sacro macros for inertias. Here is a default inertia tag. Here are the box inertia, the sphere inertia, and the cylinder inertia. Here is the transmission tag, transmission macro. And let's see here on the wheels. Let's wheels. Here on the wheels. Okay, here on the wheels I have the transmission tag, and I have a default inertia. Let's see what happens when we disable it and we enable the inertia. The model will not sync. So, so this problem practically is caused because let's concentrate only on the transmission tag. When the transmission tag loads, on this case, the model will not sync, but you will see some odd physics. It is pretty difficult to adjust Gazebo and the physics of your model. So here you see the model is rotating because there is no controller associated with the wheels. I, I'm not very experienced in Gazebo and Rust. I'm between beginner and intermediate, but those are my findings. I think it could help you to debug your RDF model. So here, and now let's enable the transmission tag. You see that the model is over the ground, but it's moving oddly. So what happens when we load the transmission tag? And we enable our inertia. And is the correct inertia because the equation is okay. Let's assume that. So here you see the model is on the ground, below the ground. So one problem will be caused by the transmission tag, but in the end is caused by the inertia. So why? The reason is I really don't know the reason, so just speculation. Is something about the controllers and Gazebo is all that I can tell you. But let's enable now this tag with the controller, so you can put the inertia that you want, and let's enable it. Okay, now the model is standing over the ground and is quiet. So that's the default mode of operation or the correct behavior. So that will cause the model syncing. So the three things that things that you need to verify about your model syncing is the transmissions. If you are, please disable it and run the demo to see if it's everything over the ground. You have to adjust the PID controls and also the inertia of the model. If the inertia is too low, probably this will cause something odd with Gazebo. But basically it's about the PID, the waves, and the inertias when you associate the transmission tag to the motor. So next thing we want to talk about is about the drifting. Sometimes when you run your model starts drifting left, drifting right, and the reason or the reasons that I thought are about some physics about Gazebo. So let's see. The first thing that we can check is the associated friction parameters between the wheels. So I use rubber. Let's see here, as you will see, I use the rubber parameter. If you 0 is no friction and a value that is let's see 10 is a lot of friction between the ground and your point of contact. So I use rubber because probably the wheels are of this material. And then also for the left and the right wheel, if you put it let's put it 0 0 oh 200. Okay, here is a 0. So let's start moving the robot to see if it comes. try to drift to one side. Let's change the camera. Okay, in my case it's not drifting. Let's see if we move it to the sorry, reset the model pose. Try to rotate to see if it rotates oddly. Okay, in my case, I think it's a little bit drifting. Let's see. It's pretty difficult to see, but I think the model is not drifting. Let's put it zero tag for friction. I mean zero value for friction. There's no friction. Let's start moving. Rotate it. So you see here, the model is not moving because there is no friction probably. Well, let's see if the controllers were not loaded efficiently. No, everything is fine. So there's no friction and the model doesn't move. That's because the physics. And let's put a low value of friction to see what is the behavior. Okay. Okay, in my case, I think I adjusted the values very well. So that's because the model is not drifting. But the first thing that you need to check is those dynamic parameters. The next thing that you need to check to see if your model is drifting, I mean, are things that are properly from Gazebo. In my case, it will be a little bit over exaggerated because and in my case that the only way that the model will work. So the first thing you need to check, let's disable the laser and all other sensors first. Launch file. Okay, let's see now. This will load the simulation faster. Okay, you have to check several things. The collisions. An example, you check your collisions. The ground is a collision frame. That's because everything is orange. But you need to check the collision for your object. If your collision uh, is not very well or accurate to your model, you have to check it. Another thing that you need to check are the joints. There are the correct information of the joints. Let's see. I don't know when I don't see the joints, but it's another thing to check. The center of mass. You have to get, I think, the center of mass correctly mapped to your model. So my center of mass is pretty good, I think, because the center of mass of the wheels are like that, and also the center of mass of the model is a little bit on the front because I have a lot of motor batteries on this side. And the next thing, you check the point of contacts. Let's see. Here you see the 3 points of contact are for the jet bot. Another thing to see is let me see. Okay, here the most important thing to check is the inertia. Here you see my inertia is not perfect, but it's the inertia that I have. At least try to check that your inertia is near your model, like in this case. Let's see. Here you have, okay, this is next. I got see one answer about the robot and what you can see on your rover. View the center of mass, view inertia, view collisions, view contacts, and here's a Gazebo tutorial about inertia. What they say is that the inertia must be closely to your robot model. As far as you see here, everything is practically right on its position. So if you have your inertia like that, also check these points, these green points. If you check your inertia and it looks like that, your model will probably works well on the simulation. So that's are the things that you can check. And also let's see here. Let's close that. Enable that. And here let's talk about the okay that in the end the drifting is caused by physical configuration of Gazebo, and that is caused by your Urdf model. You have to check the collisions, you have to check the center of mass or center of gravity, I don't know how to say it. You have to check your inertias. There are a good reference. I think in Wikipedia is listen. In Wikipedia. It will take a little bit of time because my connection thing is failing. Okay. Here you see you can check your formulas. That's the cylinder formula, the cuboid or the box formula, and also a solid sphere formula. So you can check that. let's talk about another thing that will cause your model to drift. I think that those are all the information that you need to know about the drifting. So the last thing that I want to talk about is about your URDF model. I review again my URDF model. As you see, uh, there are some things. The thing is that when I started to make the macros, I forgot to put the inertial tag. So problems that you will have probably if that you get something like that when you make your macro, you have to have also with the inertia, you have to have the inertial tag, and also you have to have to inside the inertial tag the mass, because if you don't put it, it will get you errors. The other thing is that when you disable it, let's disable the box, it will work, I think. Let's see. You see? So this probably will cause you some odd situations on the simulation, and you have to be careful about that. Okay. So recap, if your model is syncing, please check your transmission, check your PID, also your configuration of your inertia. If you are not sure, you can put some default inertia to get it work until you figure out. The next thing is that the drifting, if you see your model drifting, is about the physics. So you check your friction parameters, the inertias, the center of mass, the collision, everything related about Gazebo, because it's the simulation that is failing. And check also your inertia tags, your that you have your inertia. Another thing that I note in Gazebo is about the baseline and the odometry. I have here an issue. It's not really about Gazebo, it's more about a plugin. And the situation is like that. Let's see if we can see. We have to enable the sensors. It's about my odometry. But let's enable it to set it as default. So I have a lot of topics because I have a lot of sensors, but the one that we want to discuss here is the odometry. Let's see where it is. Gazebo robot pose here. There is something odd. Let's stop it. I configured my plugin to put the child frame ID to the base footprint and the frame ID to the base link. And when I got the pose, everything is related to Adam. If I move the robot, obviously because the child and the frame are the same, the robot will always see 0 here. So let's see RQT graph to see it more clearly. here is my TF3. For some reason, when I put the base link, the base footprint, because the base link is everything associated with the robot, and the base footprint is the fixed link, I got the odd thing that everything is related to Odom. So let's say something. Let's see Gazebo. I have here configured a lot of frames, but the most important are the base link and the base footprint. If I put the base footprint, let's see. Okay, I have the base footprint here, and if we see the RQT, it always linked in that way. I don't know why. That's in my case, and I am pretty sure that it's something odd about my model, not Rviz, not Gazebo. So one thing you can do is make your own TF. If you try to do, let's run TF, TF monitor base link base footprint. No publisher. Okay, let's move the robot to see if something happens. No. Let's. Okay. It's not TF monitor. TF. I think it's TF view, TF echo, some TF echo. TF base link base footprint. Okay, here you see you get the translation better. Okay, but when you see the gross topic echo Gazebo robot pose, it's always 0 with a covariance, you know. But the thing is that you can make a node or a plugin for Gazebo to make the get your robot pose and simulate your odometry. I'm not saying that the author of the plugin that I'm using is odd. It's all about my model, and everything is something wrong or something like that. So my workaround will be make a node to check the transformation between the base link and the base footprint. That's my way to check that. So that's all. I want to tell you about the issues or problems and how to solve it, where to check. Also, you can check Gazebo answers or Rosa answers. I get all the information here, but I want to concentrate all the information in one video. So if you have problems, please check all those things and make sure your Urdf is working. If you want to check your Urdf if it's loading, an example, you have sacro. Okay, Urdf. If you want to check your robot description, if it's loading first, that's the first thing that you need to do before load the model in Rviz or Gazebo. You will have to run this command and check that you have all the description of the robot. So that's all. I hope this will help you to solve your Gazebo and Rviz problems. I will put some other videos about my development on the Jetpack. Thanks.